Welcome back, Jaguars. Today we're going to learn all things decimals. We're going to learn how to add, subtract, multiply, and divide decimals. First, we're going to start with adding decimals. The first thing I want you to know is that when we add, subtract, compare, and order decimals, we have to always line up the decimal. So I'm going to look at first the whole number. Which whole number is bigger, 11 or 1? 11's bigger, so I'll put the 11 on top. Then I will line up the decimals. When we're adding and subtracting, comparing and ordering, it's extremely important that we make sure that our numbers have the same amount of digits. Therefore, whenever there's any missing numbers, I will add zeros. 3 plus 0 is 3. 9 plus 2 is 11. Carry the 1. The decimal falls straight down. 1 plus 1 plus 1 is 3. 1 plus 0 is 1. What happens if I'm adding a number with a decimal plus a whole number? I still look at the whole numbers and see which one is bigger. As I can see, 23 is bigger, so 23 will go on top, and then the 9 will go on the bottom. I will still make sure that I line up the decimal. Behind every whole number is what is called a ghost decimal. I will activate the ghost decimal, and I will fill in any missing numbers with zeros. 0 plus 3 is 3. 0 plus 2 is 2. Bring down the decimal. 3 plus 9 is 12. 1 plus 2 is 3. So remember, when you're adding a whole number plus a decimal, you have to activate the ghost decimal that is behind the whole number. Behind every whole number is a ghost decimal. We're going to use the same problem that we just used here, and we're going to use it in subtraction. And this will show you why it is important to always fill in zeros wherever there's missing numbers. So I have 23 will go on top. I activate the ghost decimal and I add zeros. Here's where adding zeros is extremely important. It's extremely important because if I did not add the zeros, I would just drop the 23 down. But I'm not going to do that. 0 minus 3, I cannot do that. 0 minus 2, I cannot do that. I have to steal from the 3, make it a 2, make the first 0 a 10, then a 9, and make the last 0 a 10. 10 minus 3 is 7. 9 minus 2 is 7. Bring the decimal down. 2 minus 9 I cannot do, so I have to steal again. 12 minus 9 is 3. 1 minus 0 is 1. As you can see, when we subtracted and we added our zeros, we changed the outcome of the numbers. It's most definitely smaller than the bigger number. Let's move on and do some multiplication. The first thing I'm going to do when I'm multiplying numbers is I'm going to circle everything behind the decimal in both numbers. That means I have 1, 2, 3 digits behind the decimal. Now I'm going to drop the decimals and I'm going to multiply as if it was normal. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. Put my 0 for my tens place value. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. I add those two numbers together. One plus 4 is 5, plus 6 is 11. Carry my 1. 1 plus 3 is 4. Now I come back here. I saw I had 1, 2, 3 numbers behind the decimal. I will activate the ghost decimal, and then I will jump 3 spaces to the left. My answer is 4 and 182 thousandths. Let's try another one. The first number has nothing behind a decimal, so I don't need to worry about that. I have 1, 2 numbers behind the decimal here. So then I will have 27 times 28. 8 times 7 is 56, carry my 5. 8 times 2 is 16, plus 5 is 21. Put my 0 for my ones place value. 2 times 7 is 14, carry my 1. 2 times 2 is 4, plus 1 is 5. 6 plus 0 is 6. 1 plus 4 is 5. 2 plus 5 is 7. I had 1, 2 numbers behind the decimal, 2 jumps, 1, 2. My answer is 7 and 56 hundredths. Now let's take a look at what it would look like if we're dividing. We have 3 types of division problems we're going to look at here. We have a whole number divided into a whole number divided into a decimal, and a decimal divided into a decimal. Remember, the second number in this standard algorithm is the one that will go outside the house. This is our divisor. So 4 goes outside and 7 goes inside. How many times can 4 go into 7? 1 time. When I'm dealing with decimals, I am not allowed to have a remainder. I have to keep dividing in order for me to get an actual answer. So I will activate the ghost decimal, take the ghost decimal to the top of the house, and add a 0. I will add as many zeros as I need to so that I can solve the problem. 4 can go into 30 7 times. 4 times 7 is 28. Say I still have a number left over, so I'll add another 0. 4 can go into 25 times. Seven divided by 4 is 1 and 75 hundredths. 2 and 8 tenths divided by 7. 7 will go outside the house. 2 and 8 tenths will go inside the house. The first thing I'm going to do is I'm going to move the decimal to the top of the house. How many times can 7 go into 2? 0 times. Every time I subtract, I bring a number down. How many times can 7 go into 28? 4 times. So therefore, 2 and 8 tenths divided by 7 is 4 tenths. And the last kind of division problem that we will see is 2 tenths will go outside the house, and 8 tenths will go inside the house. I have a decimal divided into a decimal. I cannot complete the problem as it is, so I have to turn the decimal on the outside of the house into a whole number. That took 1 jump to move the decimal behind to make it a ghost decimal. So therefore, on the inside of the house, I have to do 1 jump. My new problem is 2 divided into 8, which will be 4 times. Let's see another example of this problem. See, I have a decimal on the outside and a decimal on the inside. I'm going to jump 2 times, 1, 2, to make that a whole number. Because I jumped 2 times on the outside, I have to jump 2 times on the inside. 14 and 4 tenths. Carry the decimal to the top. 12 can go into 14 one time. Whenever I subtract, I have to bring a number down. 12 can go into 24 2 times. Therefore, 12 hundredths divided into 144 thousandths is 1 and 2 tenths.